Electronics Bit by Bit. This is the beginning of Project 3 where we discuss what combinational circuits do and how to analyze and design them. This is an overview of what's to come in the next few weeks. I'm really excited to share what I've learned and get to building some circuits. However, before we do that, we need to discuss the analysis and design procedures for these circuits so we can fully understand what we're doing. So, what are combinational circuits? Well, there are two types of circuits, combinational and sequential. Combinational circuits take in external data and produce an output that is only produced by the present combination of input data entered into the circuit. So here is a block diagram showing n inputs and m outputs. It's important to note that when you have n inputs, that means you have 2 to the power of n combinations of binary inputs, and for each combination, there's only one possible value for each output variable. Therefore, because of that, we can represent a combinational circuit as a truth table that, that lists the output values for each combination of input variables. The circuit can also be represented as m Boolean functions, one for each output variable, where each output function is represented in terms of the n input variables. So that's going to make a lot more sense as we do our example. So analyzing combinational circuits means we are determining the function that a circuit implements. So when given a logic diagram, we need to find the Boolean functions and the truth table that go with that diagram. And if that function has a particular purpose, we should explain what that is. So first we have to find the Boolean function. So the first thing to consider is whether the circuit is actually a combinational circuit. How do we do that? Well, a combinational circuit has logic gates with electrical signals that flow in one direction from inputs to outputs. There's no connection from the output of one gate to the input of another gate. So here we have an example of a sequential circuit where we can see that the value of Q, which is the output, is fed into this NOR gate as the input, and then the same thing with Q prime being fed into the NOR gate. So these are sequential circuits and they have feedback paths that combinational circuits don't have. In our diagram, we didn't see any feedback paths from the output to the input, so we can be confident that it's a combinational circuit. So with that being said, we can move on to step 2, which is labeling the intermediate gate. So we can see here that there's two output functions, but they're made of these intermediate functions here, T1, T2, and T3. So we're going to label the intermediate gates and then figure out what their function is in terms of the input variables. So we have T1, T2, and T3. Next, we label all the gates as a function of the input variables and previously labeled gates. So now we're finding the functions of f1 and f2, which are a product of t1, t2, and t3. So after repeated substitution and Boolean algebra, we arrive at the Boolean functions of the output gates in terms of the input variables. I put the final result of simplifying the functions using Boolean algebra in this video, but if you would like to see all the steps that went into the results, take a look at the article on my website. The link is in the description of the video. So now that we've found our Boolean functions, it's time to create our truth table. So step 1 is to determine the number of input variables for the circuit. So we have n inputs and therefore can form 2 to the power of n possible combinations. So for us, we have 3 inputs, so therefore there should be 8 combinations of inputs in our truth table. Step 2 is determining the value of each output function. So the simplest error-proof way to do this that I've found is to take the function, break it down to one term at a time. So for example here, we broke it down to A prime, B prime, C prime, and then we looked at BC prime, and then we looked at A prime or BC prime, B prime, C prime. And then we do the same thing for F2 where we have AB and then we have AC and then we have AB or AC. So now we can summarize the values of the output functions into one truth table. So we can see those results here. So now we're left with our final results, which are the Boolean functions and the truth table. Now, the point of analyzing circuits is to figure out what the circuit does. This particular example doesn't generate anything useful, but understanding what we've done here will allow you to understand the examples we'll be looking at in the upcoming weeks. Those examples will generate useful circuits that are often used in digital design. So thank you so much for watching. I'll see you next week.